Hey everybody, today we are going to learn how to do long division of polynomials. This can be used for several different things. One of the things it can be used for is finding slant asymptotes of a rational function. So first, in order to do this division, we're going to set it up like this. 3x plus 1 goes into 3x cubed minus 5x squared plus 10x minus 3. Now, in order to divide these, we're going to first divide this first term in here by the first term out here. So 3x cubed divided by 3x. Okay, so that could look like this. 3x cubed over 3x. And those 3's cancel. And this x down here cancels one of these up here, so we are left with x squared. Okay, so now we've got an x squared up here, and we are going to distribute that to everything out here. So x squared times 3x is 3x cubed, and x squared times 1 is x squared. And we are going to now subtract this binomial from this binomial. So 3x cubed minus 3x cubed is 0, so that cancels. Negative 5x squared minus x squared is negative 6x squared. And we will bring down the plus 10x. Okay, so now we're going to do that again. So we have divided, distributed, and subtracted. We're going to do that again. Divide, distribute, subtract. So we will divide negative 6x squared by 3x. Okay, so negative 6 divided by 3 is negative 2. X squared divided by x is x. Okay, so that's divide. Now distribute. Negative 2 times 3x plus 1 is negative 6x squared minus 2x. So we divided, distributed, and now subtract. Negative 6x squared minus negative 6x squared cancels. 10x minus negative, so plus 2x is 12x. And we will bring down the minus 3. Okay? And now, once again, divide, distribute, subtract. So we've got 12x divided by 3x, and that is 4. Distribute. 4 times 3x plus 1 is 12x plus 4. And subtract. 12x minus 12x cancels. Negative 3 minus 4 is negative 7. And that is our remainder. So negative 7 is our remainder, and we can write that as minus 7 over 3x plus 1, and this is our answer. Okay, so let's do one more. So we've got 2x minus 5 going into 2x cubed minus 9x squared. Now in this one, we're actually missing the x term, and we can't skip any terms, so we have to put in a 0x plus 15. Okay, so make sure that you have all your descending powers. Here we had 3, 2, 1, 0. Here we've got 3, 2, 0. We're missing the first power, so we have to put in a placeholder there of 0x. Okay, so now we will divide, distribute, subtract. 2x cubed divided by 2x is x squared. So that's divide. Distribute. X squared times 2x minus 5. 2x cubed minus 5x squared. And subtract. 2x cubed minus 2x cubed cancels. Negative 9x squared minus negative 5x squared. So that's plus 5x squared. Negative 9 plus 5 is negative 4, so we have negative 4x squared. And we will bring down plus 0x. And we'll do it all again. Divide, distribute, subtract. 2x going into negative 4x squared. So negative 4x squared divided by 2x is negative 2x. That's divide. Now distribute. Negative 2x times 2x is negative 4x squared. Negative 2x times negative 5 is 10x. And subtract. Negative 4x squared minus negative 4x squared cancels. 0x minus 10x is negative 10x. And we will bring down the 15 and do it again. Divide, distribute, subtract. Negative 10x divided by 2x is negative 5. Distribute, negative 10x plus 25. And subtract. Negative 10x minus negative 10x is 0. 15 minus 25 is negative 10, so that's our remainder. And it can be written as minus 10 over 2x minus 5. And this is our answer. Hey guys, today we are talking about asymptotes found in rational functions, and specifically in rational functions where one of the asymptotes is not horizontal. So number 8 here, you can see I have graph, and it has an asymptote that's slanted. There's a vertical asymptote right here, but it's that slant asymptote that's a little bit different. So for the vertical asymptote, you just have to see if there's an x value that cannot exist. If I put the number 3 right here for x, 3 times 3 is 9, minus 9 is 0. That gives me a denominator of 0. So the domain will not allow that. So you can see on this graph, at x equals 3, the graph will never touch that x value. So there's a vertical asymptote at x equals 3. But there's not a horizontal asymptote, there's a slanted asymptote. And here's how you can see from the equation that the horizontal asymptote is not going to be there, but it's going to be slanted instead. In this case, I've got a degree of 2 in the numerator and 1 in the denominator. I'm going to make those degrees match, so I'm going to add 0x squared to the denominator, and that doesn't change the value because there's 0 of them. I can add 0 of anything anywhere I want without changing the value. So I've got 1x squared in the numerator and 0x squared in the denominator, and 1 divided by 0 is undefined. So that tells me there's not going to be a horizontal asymptote. But what's going to happen is there's going to be a slanted asymptote. And here's how I can find the equation of that slant asymptote. I'm going to divide 3x minus 9 into x squared plus 18. So we're going to use long division. 3x minus 9 goes into x squared plus, now here's the trick, I've got to put in 0x. I've got to have all my descending powers. 0x plus 18. So x squared divided by 3x, that x is going to cancel. What I'm going to end up with is 1/3 x. And when I distribute that 1/3 x on 3x minus 9, 1/3 x times 3x is x squared. And 1/3 x times negative 9 is minus 3x. And I need to subtract those. X squared minus x squared is 0. 0x minus negative 3x is positive 3x. And then I need to bring down that plus 18. 3x divided by 3x is 1, so plus 1. And then I distribute that 1, and I get 3x minus 9, and I subtract that quantity. 3x minus 3x is 0. 18 minus negative 9 is 27. So I end up with a remainder of 27, so that's plus 27 over 3x minus 9. Now when I write the equation, what I have instead of a horizontal asymptote is a slant asymptote. And that is at y equals 1/3 x plus 1. And I leave it at that, 1/3 x plus 1. I don't put that denominator or that remainder in my equation. And the reason is that it makes no difference in the line, because on the end behavior, as our x value approaches infinity and negative infinity, this denominator gets infinitely large, which means that this fraction here ends up approaching 0. So as we go out toward our end behavior, this remainder approaches 0, which means it does not make a difference in our line. So our slant asymptote is 1/3 x plus 1. Here's another case where I'm going to have a slant asymptote because I've got a degree of 2 in the numerator and 1 in the denominator. So I add 0x squared. 6/0 is 0. So I'm going to have a slant asymptote. First, though, let's put that vertical asymptote. 3 times x minus 2 equals, or cannot equal 0. So I'll just go up here. 3x minus 2 cannot equal 0. When I move that 2 over, 3x cannot equal 2. So I divide by 3 and I'll get x can't equal 2/3. So I'm going to have a vertical asymptote at x equals 2/3. So there's my vertical asymptote. For the slant asymptote, 3x minus 2 goes into 6x squared plus 0x minus 8. 6x squared divided by 3x is 2x. And then I distribute that on 3x minus 2, 6x minus 4x. And I have to subtract that quantity, 6x squared, and that actually should be 6x squared right there. 2x times 3x is 6x squared. 6x squared minus 6x squared is 0. 0 minus negative 4x is positive 4x. And I bring down the minus 8. 4x divided by 3x is 4/3. So plus 4/3. When I distribute that, 4/3 times 3x, it gives me 4x. And 4/3 times negative 2, that's going to be negative. 4 times 2 is 8, it's going to be 8/3. 4x minus 4x is 0. 8 minus negative 8/3. Now 8 is the same as 24/3. 24 divided by 3 is 8. So I've got negative 24/3 minus negative 8/3, and that is negative 16/3. So that's my remainder. So what that means is I've got minus 16/3 times 3x minus 2. But again, as this x gets infinitely large or infinitely small, this right here approaches 0, so it's not going to make any difference in my line. My slant asymptote is at y equals 2x plus 4/3. Now we'll finish this lesson with some review of some older topics here. Find the end behavior. So we have as x approaches negative infinity, meaning as the graph goes left, and as x approaches positive infinity, meaning as the graph goes right. So as the graph goes left, what is y approaching? As the graph goes right, what is y approaching? As the graph goes left, the y value is going up forever, so y is approaching positive infinity. As the graph goes right, y is not going upward or downward forever. It is getting infinitely close to -3. this graph is decreasing first for x's that are left of -6, so less than -6. Then it begins to increase from -6 to 4, so it's increasing for x's that are greater than -6 but less than -4. Then it begins to decrease, and it does that forever to the right, so it decreases again for x's that are greater than -4. And the extrema, I see two of them, and they're already highlighted here. Okay, now this graph will never go any lower than this point, so there is an absolute minimum at -6, -7. Okay, then there's a maximum here, but it's not the highest the graph will ever go. It goes higher over here, so there is a relative maximum at -4, 1.